Hello everyone, this is Mr. Fu. Today I decided to go through the summary of chemical bonding and structure, which is relevant for the GC O-level syllabus as well as the IP syllabus. This topic is a very big topic in chemistry, where students need to relate the physical properties such as melting or boiling point, electrical conductivity, solubility in water or organic solvent, to the structure and bonding of different substances. In the syllabus, you need to know these substances: simple molecules, ionic compounds, metals, and giant molecules. So what I did was I came up with this summary table to help students in the revision of this topic. Questions from the GC O-level and IP exam paper will be testing on relevant concepts from this summary table. So this will serve as a good summary for you in your revision. I will just briefly go through with you the summary. If you are interested in more videos, please subscribe to my channel. Very soon, I will only be opening up some of the exclusive videos to my subscriber. So you must quickly subscribe so you get to see exclusive videos, and I will also provide my subscriber the updated summary notes and cheat sheets. So I'm going to do a comparison between simple molecules and ionic compounds. It's important to recognize the difference between elements and compounds. These are the common elements and compounds that will be tested in the examination. As for melting or boiling point, the way to explain their low or high melting and boiling point follows the same template. The template is this: structure, bonding, particles, energy. I call it the SBPE template. S stands for structure. B stands for bonding. For example, ionic bonding, electrostatic force of attraction, or intermolecular forces. Particles is represented by P, refers to ions, molecules, or atoms. Energy, does it require a lot of energy to overcome the forces of attraction, or little energy is required? So for simple molecules, in general, they are of low melting and boiling point. You need to talk about them as simple molecules with simple molecular structure. There exists weak intermolecular forces between the whatever molecules they are mentioned in the question. For example, methane, water, carbon dioxide, etc. Hence, little amount of thermal energy required to overcome the weak intermolecular forces, so the substance has low melting and boiling point. For students in the IP syllabus, you are required to know what is hydrogen bonding. Hydrogen bonding causes the compounds to have a higher melting or boiling point than simple molecules with only weak van der Waals forces, as hydrogen bonding is stronger, requiring a larger amount of energy to overcome. As for ionic compounds, they are of high melting and boiling point. So this is how you explain why their melting and boiling point is high. They are ionic compounds with giant ionic lattice structure, with strong electrostatic force of attraction between what ions and what ions. You must mention the specific ions in this ionic compound. And because of this, large amount of energy is required to overcome strong electrostatic force of attraction between opposite charge ions. Now, moving on to electrical conductivity. For simple molecules, in general, they cannot conduct electricity in any state. There are exceptional cases, but in general, they do not. So the reason is absence of mobile ions or delocalized electrons. Both must be mentioned. You cannot neglect any one of them. And the important keyword that must be mentioned when it relates to electrical conductivity is absence of mobile ions or delocalized electron to act as mobile charge carriers. This is very important. As for ionic compound, you must remember they can only conduct electricity in molten and aqueous state, but not in solid state. What is the reason behind this? In solid state, the ions are held at fixed position due to strong electrostatic force of attraction between opposite charged ions in the giant ionic crystal lattice structure. You need to mention about the forces of attraction and the structure. And because of the forces of attraction, they are very strong between the ions, they are held at fixed positions. In molten and aqueous state, these ions are free to move around because the force of attraction are overcome. You do not need to know the detail on why the force of attraction is overcome. Basically, the water molecules is able to separate the ions from each other. The water molecules are forming stronger interaction between the water molecules and the ions. And because of this, the ions are no longer held at fixed position and are free to move around to act as mobile charge carriers. As for solubility in water and organic solvent, you do not need to know the detailed explanation at GCO level. You only need to remember simple molecules are soluble in organic solvent but not soluble in water. There are exceptional cases like acid, ethanol, and sugar. For acid, it is because it dissociates or ionizes in water to form hydrogen ion and the anion. Ethanol and sugar because of hydrogen bonding. As for ionic compound, they are soluble in water because there's ion dipole interaction between water molecules and ions. As I mentioned just now, the water molecules is able to form strong interactions between itself and the ions. But in organic solvent, ionic compounds are insoluble. Now, the other two substances that you must study is metals and giant molecules. For giant molecules, you need to know the three examples in detail: silicon dioxide, graphite, and diamond. For metals, they are of high melting and boiling point. Again, we are looking at structure, bonding, particles, and energy. So this is the standard template that you must demonstrate or you must write down when explain the high melting and boiling point. All right? So talk about the strong electrostatic force of attraction between the positive sodium, potassium, calcium ions, whatever is given in the question, and C of delocalized electron. Then you relate to a large amount of thermal energy to overcome the strong electrostatic force of attraction. As for giant molecules, there are a lot more to say because you have three different giant molecules to study. Basically, they are of very, very high melting and boiling point. For diamond, you need to mention how each carbon is covalently bonded to 4 other carbon atoms, and which in turn are bonded to 4 carbon atoms in a tetrahedral structure. This must be mentioned. You need to mention the number of carbon atoms involved, how many is bonded to how many, and what type of structure do they form. So it forms an extensive 3-dimensional structure. Okay, extensive means the bonding is repeated throughout the structure, which means it is really a very big structure. Because of this, it requires a lot of energy to break the strong covalent bond. Remember, for giant molecules, the covalent bond need to be broken. For graphite, it is different from diamond. Each carbon is covalently bonded to 3 other carbon atoms, which in turn bonded to 3 carbon atoms to form a continuous layer of hexagons. Diamond, tetrahedral. Graphite, hexagonal layers. This also forms an extensive structure and requires a lot of energy to break the strong covalent bond between carbon atoms. But if you compare between graphite and diamond, graphite has a lower melting and boiling point. It is not as extensive as compared to diamond. Silicon dioxide. Silicon dioxide is the compound representing the giant molecules you need to study. each silicon bonded to 4 oxygen atoms and each oxygen bonded to 2 silicon atoms. And this form an extensive 3D structure requires a lot of energy to break the strong covalent bond between oxygen and silicon atoms. So the phrasing is very similar, just tweak a bit. As for electrical conductivity, metals are good conductors in either solid or molten state. The reason is the outer electrons of metal atoms can break away easily with outer electrons moving freely within the metal lattice. These mobile electrons moving freely act as mobile charge carriers. As for giant molecules, diamond, they are not a conductor of electricity because all the outer electrons are used for bonding with no mobile electrons available to act as mobile charge carriers. So in explaining the electrical conductivity, talk about the bonding, talk about the structure, mention about the mobile charge carriers, whether they have or they don't have. Silicon dioxide is also a non-conductor. All outer electrons are used for bonding, no mobile electrons available throughout the structure. So I'm trying to make the phrasing more or less similar so that you can actually study them as a whole. You don't have to memorize too much since they are overlapping with each other. Graphite, each carbon atom has 1 outer electron not used for bonding. This delocalized electron that is not used for bonding is free to move along the layer. Remember, the delocalized electron is only free to move along the layer. It doesn't move between the layer, all right? So this delocalized electron is acting as mobile charge carriers. Solubility, you can read yourself. Basically, the most important part is to remember that metals are in general not so soluble in water, except the group 1. And in organic solvents, they are not soluble. As for giant molecules, right, they are not soluble in water because the water molecules is unable to overcome the strong covalent bond between the atoms. Other properties that you must study is density for metals and malleability and ductility. Density-wise, you need to talk about how the atoms in a metal are packed so closely together. And within a unit volume, you have a large number of metal atoms, which constitute high density. Mass per unit volume gives you density. So within a unit volume, if you have a large mass of substance, then the density will be high. And they are malleable and ductile because when they are arranged in orderly and rigid arrangement, applying a force on them, causing the metal ions or atoms to slide over each other easily. When they slide over each other easily, right, you need to talk about how this will not disrupt the metallic bond between them. Between what? Between the C or D localized electrons and positive metal ions. So you need to be very clear what are the points that I need to mention. All right, always think about the structure, bonding. All right. As for giant molecules, they are definitely of high density. You can read yourself the information, and they are considered hard. Remember, when we explain melting and boiling point, we relate to energy. Okay, so melting point or boiling point, think about energy. But when we talk about force, like hardness, strength, for force, right, you relate to the strength, hardness. So you need to be very clear on the difference, all right? For graphite, they are soft and slippery because of the weak intermolecular force between them. So the layers of carbon atoms is able to slide over each other easily when a force is applied. The word when a force is applied is important. Sometimes students may forget to mention this. Okay? Now, so I hope you can benefit from this session. So I hope this will help you. Okay, that's about it. Thank you.